Awesome. Hello, everyone. So, before we start, everyone would like to embrace the fact that John is actually the cameraman there. All right. So, few people ask me. Oh, you don't see. Yeah, I've been having these issues with those projectors before, so that's gonna be funny. The first question that I had was, for this workshop, do I really know Scala? And there's a simple answer to that, and that is yes. So we only have 6 hours, and 6 hours seems like a lot, right? But I honestly cannot do intro to functional programming and intro to Scala in the same time. It's just impossible. Like if I were doing maybe in Haskell, then maybe, because some concepts in Haskell are already built within the language. With Scala, we have to rebuild them from the scratch. That way, if you've never seen Scala code base before, I would reckon, like, we have so many other great workshops right now running. I'm just saying, it would be just a shame to waste 6 hours of your time. So, like, how many people here haven't seen Scala in their life? All right, few people. I mean, I'm still gonna do like small intro to Scala for the first 30 minutes, but it's sort of more considered as a recap. So everybody's on the same ground before we actually move on to FP. You might stay, but that might be a little bit of a challenge. Now, some other people ask me what exactly we're going to learn, because intro to functional programming, that might mean many things to many people. So I created this little syllabus here. So all those things that actually will be covered are here. So like if you need the nouns, those are here, basically. So if you also know all that, then maybe that's not the workshop for you. But if all that seems weird or crazy, you're in the right place. All right. Nobody actually did leave. I mean, don't be discouraged. I mean.
So what exactly does it mean to know Scala but not know any of those?
Okay, so you need to understand like a basic syntax. And you need to know at least what implicits are. You don't need to be fan of implicits. I get that. But you need to understand what those are and how they work, because some constructs from FP we're going to build on top of implicits. So implicit is like a machinery that we're going to use, and it's something you've never seen before, then you might struggle. I will still try to cover that, but I'll be try to speak as fast in English as I can. All right. So about this workshop, you need to fetch GitHub repository, which is here, and if you could do it right now, that would be awesome. Also, a good thing to do is fetch Scala Z resources as well. I mean, if you are using IDE, and an IDE will fetch resources for you, that's fine, right? But if you're not, then probably having a Scala Z resources is actually a good thing. There would be another question, what about cats, right? I would like to do FP with a cats library. Can I still be in this workshop? Yes, you still can. Basically, cats and Scala Z, they try to solve the same problem. They try to fill the gap in having some FP machinery within our Scala code base. In cats, they sometimes have different naming conventions, which I think personally it's unfortunate, because they tend to try to be a more newbies friendly. But then again, they're using new names for some things which already have established names in the FP paradigm. But besides that, it's going to be exactly the same stuff. So maybe the implementation is a little bit different, but all that is pretty much the same. Yeah.
Are we going to be looking at Scala Z?
At the Scala Z source code, was that?
Is it called Scala Z or Scala? What is it called?
Scala Z or Scala Z? I don't know. Scala Z.
Are we going to be do we need to code it?
I mean, I will be definitely looking at the code base. It might be actually reasonable to have code base, because some of the exercises will require you to look for some methods which are there. So you either go with documentation, which you can always find on the internets, right? But I always find working with code base better, because type signature is one thing, but then if you see how some stuff is implemented, there's an additional set of knowledge that you actually get. So I would say you don't have to, but I would highly recommend it to actually clone this repository as well. Quickly, who am I? So my name is Pawel Szulc. I came here all the way from Poland, but that was like a week ago, so I'm no longer jet lagged, which is awesome. However, I made a little mistake yesterday because I reckon, oh, the weather is so nice. Last week we had snow in Boulder, so I will do hiking, right? That was a mistake because I had this idea. Okay, so I will do hiking for 3 hours. I will be like probably something around 3 p.m. in Boulder. Then I can finish my workshop, this workshop. We ended up in the mountains and all the trails going back to Boulder were closed. So essentially, after 5.5 hours, we ended up in the different town, not Boulder, doing like 20 kilometers, which is something like 12 miles. So yeah, that was fun. So if I fall asleep somewhere in the middle of the workshop, please just wake me up and I will be fine. Now the question is like, I have so many people, I was not expecting this amount of people in my workshop. So I have like a general question, who are you guys? Like let's just raise your hand. Like I'm doing Scala for a living. Okay? I'm not doing Scala for a living. All right, please keep your hands. I'm doing Java. Okay, I'm doing Python. All right, I'm doing some other languages on JVM. Okay. How many of you guys actually are familiar a little bit with FP? Have some just a general understanding of FP concepts? Well, that's half of the crowd. Awesome. The idea behind this workshop is to sort of fill the gap. When I was 2 years ago, I was excited with functional programming. So what happened was I was sort of learning about functional programming. Then I came to LambdaConf in 2015. My ego, which was at that time very high, like I'm Java developer, senior Java developer. Then I went to all those presentations. The ego dropped, and then I was excited with all the paradigm. I was reading stuff, but I had this dilemma. I know a little bit of this. I know a little bit of that, but I couldn't really grasp how to put all those pieces together to write a simple application, like a web application, all that. And I always felt like once I'm actually going to get it, I will do a workshop about it. And this is the workshop I'm hoping to provide to you guys, so you guys don't have to struggle. We have only 6 hours, so I probably will fail. But I hope I will just put as much as information into your brain, so you guys will be able to figure the rest of that stuff on your own, especially since we are having 3 days of LambdaConf conference here. So definitely, we like the syllabus you've seen before. It will definitely help you out to see and understand other workshops, which are in different languages as well. But the concepts in FP are pretty much similar. All right, so this is pretty much it. You need to have Scala on your computer installed and SBT. Who hasn't get that on his machine? Missing SBT? Don't be shy. Well, then do it right now, okay? If you go to, there's the internet isn't great. Okay, so if the internet isn't great, well, that might be an issue. But I would say just try to at some point like install Scala, install SBT, and run SBT compile to fetch all the dependencies. I'll be doing like a small intro to Scala language right now, so we have a common ground about the Scala language. So in the meantime, hopefully all the dependencies will be fetched and we'll be good. One more thing about this workshop is like whenever I do a conference talk or workshop, I tend not to actually use a text editor. I always have tremendous amount of slides, and I never do live coding. Today I have 0 slides, or maybe a little bit, and all I'll be doing is live coding. But so there will be failures, and but the reason for it is that you can guys follow with me. The idea is not to only that just watch what I'm doing, but actually type that thing while I'm doing this, because I think that's the only way to actually learn FP. If your brain will work better with those concepts if you actually type them in. All right, so are you ready? Yeah. Sleepy? Excited? Sad? All right. So there is a file. So I need to figure out the resolution. Is that okay for you guys? I'll be fine with that resolution.
Can you switch off the lights over there?
I don't know. Can we switch off the lights? Yeah. I have absolutely no idea. That's not it. That's not it. All right, so as I said, let's try to within 30 minutes do a very quick recap, or maybe even less than 30 minutes, hopefully, about basically this is more about Scala than FP, but we'll be covering some like some very basic concepts like function composition, partial application, all that. Hopefully those are stuff that you guys already know. If you don't, you'll be fine. But just let's get started. Okay, so this is how you define function in Scala. Pretty much like the simple lambda, you put a name like func, and you have a type signature, so the function goes from string to integer, and then the body of that lambda is basically going to be just your argument followed by an arrow, and then the body of that function. Scala comes with a syntactic sugar, so you can just pretty much say something like this, and this is pretty much the same. So it gives you like a syntactic sugar to create a lambda expression. Now, if I have, let's say, a function that takes two arguments, integer and integer, and gives me an integer, I could do, put those two arguments and then an arrow and then the body of my function. But I could also use that syntactic sugar to provide a simpler definition of that lambda. So we normally use, when, for example, I have a list, and a list have a function map, which takes a function as parameter, I could just provide those functs I just created, but I could also inline the definition of my function, and this is most probably when people actually are using the sugared version, because it's just you can read it nicer. And if you've never seen Scala code base before, we tend to override the underscore like very often, but I'll not be doing that. Most probably whenever you see underscore in my presentation, it's either pattern matching or I'm using this to make a syntactic sugar for lambda expression. Now, function composition. This is actually, one of the reasons, like, people tend to think like functional programming is all about function composition, but if it was only about function composition, then we wouldn't be able to actually do interesting stuff. And so I'm going to cover function composition, but I hope you guys actually know how that works. So this is a function f that basically goes from integer to integer, and I have a function g which goes from integer to string. So now I can reason about function h, which goes from integer to string, by simply composing those two things together. And if you're familiar with this mathematical syntax like this one, this is pretty much the same thing that we're actually doing. So we can actually say g compose f. And that gives us a new function. So this thing gives us a new function which will compose those two guys together. So sometimes people like the compose method because it's close to what you would normally find in the mathematical expression, because it just relates to that way of composing functions in math. But sometimes it's actually easier to reason about your functions in program by using and then. So and then is something pretty much the same as compose, but it goes the other way around. So it's still composing your two functions. You just read it the other way around. You're just saying, so my new function will first call f with argument, and then result of that function f will go to the argument of function g, and so on and so forth. So if I had more functions, it would be just like, and then k, and then t, and so on and so forth. So far, so good? All right, awesome. I normally will reload. I would normally check if that compiles, but normally I have more space on my screen. Here we would just have to just basically skip between the text editor and terminal. Okay, so Scala Z comes with those two operators, and those are pretty much compose and then. I tend to use them because they seem nicer. And I understand there are people who hate operators. They were like, what, this is weird. But just think about it for a minute. If there's a thing that you use often, it's easier to actually reason about the operator. You have to understand what the operator does for the first time, but then once you actually know, it's actually easier to use it. So just to give you an example, if you are really into operators and using them, just an example, which language would you rather prefer? The one that gives you the ability to say 5 plus 10, or the other one which will give you the ability 5 plus 10? Which one you prefer? I know there are people who prefer the second one, I know, but majority of people would prefer the first one. Why that is? Well, basically because we are so familiar with plus. I mean, I hope everybody been in like elementary school, right? hopefully. I mean, I was, and they taught us the plus operator, and ever since plus meant the same thing. So so the function composition you actually tend to use a lot in functional programming, and it's once you actually learn the operator, it means and then, or this one actually means compose, then you tend to rather use it instead of just using words. All right, the next step is something which is called in functional programming higher order functions, and there are like whole papers about higher order functions. But I do apologize. The projector is just killing few lines. I have a little bit more on my screen, so I have to always like look. If you guys don't see something on the screen, just let me know because I might not see it. Okay, so this seems like a very, very complex thing, like higher order functions. Like I mean, God has to be like a functions on steroids, but it really isn't. It's just really a function that will either take other function as parameter or return you a function as a result. Nothing really to it. There are some languages which allow you to do that, like Scala. There are some languages which will not allow you to do that. I would say, like, if you have a language which will not allow you to do that, then you're pretty much screwed because cannot really do a lot of functional programming. So in this example, we have here a function that takes a string and gives us a function and result, and we have another function that takes a function as parameter and gives us an integer as a result. And well, those functions are pretty much being used here. So when we call the first function with argument string, we get, as a result, we get a function back. And in the second example, if we actually can provide a function as argument and to the half2 function, and we get the integer back. Everybody on board? I'm trying to talk really, really fast because there are more interesting concepts coming, so I just want to quickly go through all those things right now. If you guys have questions, just yell. I don't understand. The next FP concept is called carry, and an idea behind it is if I have a function that takes 3 parameters, in this example integer, string, and double, and gives me a long, I would like to have in return a function that will always take 1 argument. So this function, which is called carried here, will take only 1 argument, which is an integer. As a result, will give you a function that takes a string. Then that function, as a result, will give you a function that takes a double. And finally, when you call that function, will actually give you a long. So going from function that takes 3 arguments and gives you a result to a function that is like a chain with always only one single argument is called carrying. And you get that from Scala for free by just calling carried. If you do that, this should hopefully compile. Still, I guess, yeah, it's compiling. So and that's pretty much what it's doing. So now you have that original function and you carried it, and now you have a function that takes just always 1 argument. So what you can do with that is you can partially apply it. So now, for example, I'm calling my carried with 10, which applies the first argument, the integer. So what I'm left with is a function that takes a string, which will return a function that takes a double, which will eventually return a long. In Scala, we also have something which is called partial application. So partial application is sort of like carrying, but also giving the argument immediately after you carried your function. So in this example, I can call my, so let me just put enter here. I can call my function and I can provide the first argument, but then I can say the other 2's are not known yet. So in result, you will get a partially applied function with the first argument. The nice thing about it is you can actually do that with any argument. So you might say, I don't know what the integer is yet. I know the string is high, and I still don't know what double is. So what we get in result will be a function that takes an integer and a double and gives us a long, because string is already applied. So far, so good? Yes. Awesome. Now, the real dilemma in Scala, what's the difference between function and a method? And apparently that's the concept. Like, I have few colleagues in the company I work right now, which used to be Haskell developers, and apparently the thing that they struggled the most when writing Scala code was the concept of a method, because they never had methods in Haskell before, and now that's a thing which is apparently in the language. So we have some class foo here. It has two things. It has func, which is a function which we have basically like a lambda expression, but it also has this thing which is called method. And if we instantiate a class of type foo, object of class foo, and we call both func and method with some arguments, they will give us the same result because they do pretty much the same stuff. But there's a little bit difference between those two. Function is a value. We call it sometimes, well, basically it's a literal, but it's a value. Method is strictly bind with the object within which is created. If you actually look at the bytecode that is created for that class, method on the bytecode level, method will not take one argument, it will take two arguments. The first argument will be foo, will be this, right? The object that it's within created, and the second one is integer. But that's more like a detail of how actually Scala works underneath. The practical difference is, well, let's actually see. The question would be, could I do something like, let's say I have a function. Let's say I have a function that goes from string to integer, for example, right? And I would just say, I don't know. Let's say to int. So this function basically explodes if the string is anything different than the number. And now I could right now say something like temp and then foo func. So what I'm trying to do is build a function that will go from string to what? Back to string, right? Basically, because so my temp function goes from string to integer, and then func goes from integers to string. So after composing those two together, I should get a function that goes from string to string. Make sense? Will that compile? Hopefully. Now the question would be, can I do exactly the same thing? So I1, whatever. Could I do the same thing, but I would not call foo func, but method? Will that compile? Well, it really shouldn't, but it does. Because underneath Scala is like trying to help you out. Like it's like oh, okay, poor user, I will help you out. But to see the problem, let's do something else. Let's have a temp. So let's have something the other way around. So now we would like to have a function that will go. So temp2 that will go. Wait a minute. So what we want to do is we want to call like foo func, and then and our function temp2. So foo func will go from integer to string. So our temp function has to go from string to whatever. Right? Let's let it go back to wait, what? Can I actually reuse my function? I could actually reuse existing function. So I could reuse temp. I could do something like that. So func goes from integer to string. Our temp goes from string to integer. So finally, what we get here is a function that goes from string to integer. All right, let's compile. Oh wait. Yeah, it's from int to int. Sorry, you're right. Compiles. All right, awesome. So now the question would be, will that thing, like if I use method, compile? And now it won't, because the reason for that, if we actually look at the Scala, we can actually do it. We can go to Scala, and you don't have to do it, but just to show you the basic, like functions, how they are implemented within Scala language. They are pretty much objects. And the apply method is actually the function that does stuff, that's the body of your function, and they have compose and then implemented within them. Now a method is not a function, it's not a value, it's just like a concept we build within the JVM language. That's why it does not have the end method or compose in it. So now the question would be, well, what can I do about it? Well, there will be two questions. What can I do about it, and why the hell this thing compiled? So first of all, what you can do about it is you can, on the temp method, you can put an underscore, which is like partially apply the method without any arguments. It just change the method to a function. So what this thing is doing, this guy over here, is just changing the call to your method to a function. So it underneath, it will create a function literal, a value that will, the body of it will just recall the method underneath.
This underscore should be after foo.method.
Oh yeah. Sorry. Yeah, you're right. I do apologize. It's supposed to be like that. So, and it will have to be like this. Thank you. So yes. So you need that to actually work with a method when you whenever do like a function composition and all those little things. Now the question would be, well, why this thing worked, right? Because obviously temp is a function, and then as a parameter it takes another function. We just gave them a method. So what Scala will do for you, it will just do this for you underneath in the bytecode. It's going to be like, oh, pull little follower, this is what you wanted, so here you go. This brings a lot of confusion, so I'm just putting it up front so you guys understand like how those things are working together. Now, the last thing that we will cover about functions and methods. Well, methods are nice. Yes?
What does the underscore operator do?
Okay. So I will just show you. It will. So now, foo is a method with. Method is. This should be called something else than the method. But if I do foo method underscore, it will give me a function which represents. So it will give me this. So it will give me a function literal for free, and the body of that function will internally just call that method, right? It just do this little trick for you. It essentially what it's doing. It's doing this. It's doing blah from int to string, and I would have something like I integer, and I would call foo method with that int. So it's doing this basically for you with that underscore. So
you have underscore before dot to string as well.
which one?
That's basically
As I said, that's unfortunate. Like in Scala, underscore is overloaded so many times. So this so this is confusing. Don't worry about it. Everybody's confused. So basically, this underscore is a sugar for creating lambdas. Like when I know I'm having like a lambda with one argument, and the only thing I'm going to do with that argument is just some call function on it. Then hey, I can just call like underscore and then method, and I'm here and I'm ready. But also underscore is used here to like partially apply that method to create a function for you. Okay, and the last bit about functions is that, well, with methods you get this nice little feature. Sorry, I'll just make the font a little bit bigger. It gives you this nice little feature, which is ability to have a polymorphic types within your method. So now I'm saying I have some method bar, which is parameterized by a, b, and c, and I take a as an argument, b as an argument, and I take a function that takes a and b and provides me a c, and I call c. Right, so that means pretty much I'm not really aware of what the type's going to be. I'm just saying those are some types that will fit in here whenever I'm calling that function. So I can call bar, and I can parameterize an end and end. So all those elements a, b, and the final value c has to be an integer, but I can also call it with string, integer, and double. And now if you're wondering, like people tend to say like Scala is ugly because they see this, and like, obviously it's weird. You could remove that. Scala will be able to infer those types for you. I'm sorry. I tried to put those types in square brackets explicitly, so we know with what kind of types we're dealing with. But if that seems ugly, obviously it is, and normally you would do something like that because Scala will be able to infer the type for you. Now the last thing that we will be using that to a very extent is ability. Well, here we just parameterize our types from a, b, and c, and we don't have any information about what a, b, and c is. It can be an integer, it can be a string, it can be a double, it can be a user, it can be a functor, it can be a monad, right? It can be pretty much anything. But we also have an ability to talk about like type constructors. So here I'm saying f is not really yet my type. F is something it's something that takes also type parameter. So if I have for example option, right? Option takes a type parameter. The option will fit pretty neatly. So here I'm saying I'm having an f will be something that will eventually construct, because option is not really a type that you can use, right? You just don't you will not say something option. That's not really a thing, right? You have to say option, let's say of type string. That's your type. Option of type integer. So we are here saying f is going to be something that has ability to construct the final type, and it takes one type parameter when it's constructing that type. And that's why I can actually use my option here with int. I can have option here with string, and the only difference is that here we are saying that the value f will be an option of a. So if a was string, I need to have option of integer. Sorry, if it was integer, it has to be an option of integer. If it was string, it has to be an option of string. Now already some people who are familiar with Scala, they construct most of the time. This is the way that you guys construct option, right? Option of integer, and we close over 10 over sum. I tend to use overloaded I tend to use functions from Scala, so this is pretty much the equivalent. The difference is it's in types, because the type that you get here when you construct this, it's actually underneath. The type is f sum. This is basically the type that you get. If you call this function from Scala, the type that you will get is option of int, and it's pretty useful sometimes, and we will see that probably in a minute. Now the last thing, and this is pretty scary, and I'm pretty familiar. This is scary, so I left it as a last thing to actually show you guys. Is what happens if I have a thing like, for example, either type. So either type is like a disjunction. So I can say like string or integer. You might, if you've never seen Scala Z before, you might be more familiar with a concept from basically from Scala standard library. So like a string and integer. So those are pretty much the same. The Scala Z is a little bit better, and we will talk about why that is. But now, if I would like now to try call my bus function for that type, well, I cannot really do that. Well, because first of all, it takes two type parameters. Now, in here, I put those type parameters to be for either. If we look at either definition, it's basically a and b, right? And our bus function takes something that has only the single one hole in it. And what we can do about it? Well, Scala. So let's say I have. So let's just kill this. Val either temp. Let's say temp. Let's say I have this, right? And I would like to call my function bus for that value. Now. The question would be, what would go here as a type parameter, right? And obviously I want to call this with temp. So f was supposed to only take one type parameter, but here we have a type which either by definition takes a and a b. So what we can do, we can on sort of on like a type level apply one of the types. And Scala has nice syntax for it. It looks like this, which is, and then you have to say it's going to be either of, and let's say you apply string, and then you provide a, and then you say it's going to be a type that already have string applied, and the other type, the b, is something that has a hole. Obviously, that's just ugly, and that's why we have. Whenever you have a language which struggles with syntax, you build macros. And this is the macro that we have. So we can say and this is a macro that you guys have already installed within this project. It's called kind projector, and I could say string and provide a question mark. And we'll be using this in some of the examples further on. That's why I'm just saying. Underneath, it's just building that type lambda expression, the ugly thing, but it's just easier to read this thing. If that seems ugly as well, then you can do one thing. You can provide type alias. So you can say, say something like error a, right? And you will say it's actually an either type string and a. And then now you just constructed a type with which has that one single hole in it, right? So then you would be able to just call with that error, right? It's just the same thing. The only difference is we sort of explicitly saying there's going to be this type based on that previous type. Yes.
I was going to compile the dot sum method about, I guess, method for both the integer and string.
Where are you?
You had it standalone before. You have it.
Yeah. Like so, you say like. So you're saying like option of.
Simply even just straight to the interpreter with type.
Okay, so because that sum this sum comes from this import.
Is that the Scala thing?
From the Scala, it's a Scala thing. So you need to have this. Like if you're using.
I'm still waiting for that install.
Okay, so I do apologize. So yes, so this sum comes from Scala Z. So you need to have those imports to actually.
Import that. The very integer itself is different.
No. Normally in Scala you would just constructed this. You would just say, this will work without Scala Z. But what Scala Z will give you is this.
So it's not the integer is important, it's extra.
It's the extra function. Yeah. All right. So far so good.
Real quick, so is there a reason why you have a f of underscore rather than just f of a? Did you get something special with that in the buzz definition?
No, not in this example. Like if I say f of a, then it would mean like if I say f of a here, right? If I say something like this, f of a, like that, right? Then the type that I would have to provide, this is like a full type, right? Then I have to say option of a, of int here. It's already a fixed type. And here I was just saying just any f, and it doesn't like seem in this example why would I do that, but just that's basically the difference, and we're gonna see that in a moment. Just reason about it for a minute. Option takes a type as a parameter, and you just say option, like you're saying this is my type constructor for whatever is going to be used underneath.
But because you've also defined those other ones, it kind of ties them.
Yeah, it kind of ties them together, right? Because I'm later on I'm saying I'm going to have f of a here. I'm saying I'm going to have f of a, and that's why it is. But wouldn't have to be, right? It could be anything else. All right. So yeah. So this takes longer than expected. So really quickly, pattern matching. Like I'll have to quickly go through pattern matching. It's another file within the same folder. So pattern matching seems like basically like a switch on steroids, but it really isn't. So here there are some examples. So okay. So who's not familiar with pattern matching? Raise your hand. Okay, there are a few people. So basically, it gives you ability to reason about the structure. You have some value, and you want to reason about the structure. So, for example, if I have a boolean, so go to the gem, which obviously I should do, is a function that gives me a boolean, and I can pattern match. So this is what I do. I do match, and I have some case statements, and I say whether if the value is true or false. And I return a value, in this example string. So this is basically the type is going to be returned is string, and that seems like a switch statement on steroids. So here the gem, for example, this function also takes a month as a string, and depending on the month, I give you a value. So nothing really that you wouldn't find in an if statement or a switch statement in like any other language. There's one thing worth knowing. Like for example, I see so many values which return false. I could pretty much delete all that. Without this, I could pretty much delete all this, and I could say case. And this is the last time we're going to overload underscore. So I can maybe it's Scala, never knows. But I'm just saying. So it's a different underscore from the other two underscores that we've seen, and it's pretty much saying for those two values, give me true. For whatever else, I don't really care about the value. Give me false. If I actually cared about the value, then I could say just, for example, a, and that whatever is in that pattern match will fall into that a as a variable. So, but that's still like a simple like a switch statement on steroids, where pattern matching actually shows its power is when you decompose things. So for example, list in Scala and other functional programming languages is built on the concept that you have that there's a list is either a nil, so it's an empty list, so that's one constructor to create your list, or it's like a tuple of your value, your first element, and your tail, where tail is just another part of your list. So when you have a list 1, 2, 3, you will have 1, your tail, which will be another list, 2, your tail, which will be 3, your tail, and tail will be nil, right? Make sense? And then if I pattern match against it, I can pretty much like pattern match against those constructs. I can say, okay, so if list has 3 and 4, returns this. If list has 1, return this. And there's also ability, so there's one way of pattern matching, there's another one overloaded with those cons, 1, 2, nil. And the way the pattern matching works is that, do I have, no, I don't. So let me quickly, this is taking too long. So the way pattern matching works is I could say, for example, I could call check with list 3.4, right? So do you guys have any idea what the result might be? So what I will get here? The string 3.4, right? Hopefully, because it's live coding, things might go wrong, but yeah, it works. Now, if I for example say right now, if I say 1, 1, 2, the result will be 1, 2. But check this out. If I change the order of those two lines, 27 and 28, if I do something like this, then if I run it, well, compiler will tell me I'm doing a crazy stuff, but also the value will be 1, 2, and that tail. And the reason for that is, even though my list was just 1, 2, and nil is still will fit into that category. Nil is still a list. It will still fit into other. So it will just pattern matching works. It just goes from the top to the bottom, finds the first pattern that will match, and if it does, it will give you the value, right? But compiler is saying like, listen, man, this is crazy, right? The next case statement will never be caught at this point. So you just read warnings and you should be fine. All right.
Anything we could replace other with, that would mean any non-empty list. What would that?
What's that?
Say we wanted to keep the order you just had.
Yeah.
How would you make the other more particular and make it be any non-empty?
Like you want to have the previous order? The one that we have right now or the previous one?
The previous one.
Okay. And what do you want to do?
In more particular, we could put for others so that any non-empty list.
Yes. Well, you're going to see that in a minute. It's called guards. So when you do pattern matching, you can actually, so here I'm doing pattern matching, and I'm not really pattern matching. I'm just saying whatever fits under category, right? Anything that fits under that list will fit. But wait, not really, because I have an if statement, and I'm saying, well, only if the size of the list is bigger than 3. So guards in pattern matching gives you this ability to say like, well, this pattern, but only if the Boolean expression in the if statement actually is true. So if I call it with any list size bigger than 3, I will get this case statement. If anything smaller, then I will get this case statement. All right. So, what? Yes.
In case of like going off of this example, like say you had case 1 appended with 2 appended with other.
Okay, sorry, I have to apologize. This is not a Scala course. We're supposed to go like 20 minutes. It's already 45, so we really have to just keep on going. Like maybe with the examples we're going to see, it will make sense. But the important part here is this: like if you have some kind of structure here, right? Like soldier, which can either be a robot and a human. And they will go to different places like headquarters or battlefield. And I have a function send to, and I take a soldier. So this is a trait soldier, and we have case classes for both robot and human. If our classes within Scala are case classes, they give us this ability to pattern match against those classes as well. So I can say human life, and what I will get that life here will be that life over here. So I can reason about those values. So for example, for human, I can say if battery is smaller than 10, then headquarters, otherwise go to the battlefield. So I can also decompose my structure. So if my structure, especially if my structure, for example, let's say every human will take a robot as an option, right? We can reason about it as well. We could say what happens if it's actually some robot with some battery. Yeah, I don't know how to type. Or what happens if it's actually there's There's no robot. So we can and this is a true power of pattern matching. We have some, whatever the structure that we're dealing with, we can decompose it and reason about what should happen dependently of what that structure does. And pattern matchings are everywhere. So for example, I could pattern match when I'm calling a method. I guess I'm going to skip this. The maybe most important thing is, if I have, for example, check this out. I have a list which takes tuples of not tuples, but like triples, like a tuple with 3 elements in it, and I would like to only see the ones that have 0 in the middle and 1 in the ending. I could just call on that list. I could call method filter, and filter takes lambda expression as an argument. So then my lambda expression would be like, for every argument, if the second element of tuple is 0 and the third element of tuple is 1, well, it's okay, we keep it in the list, anything else should be dropped. But I could also use pattern matching, and I could just use something which is called a partial function. I could just say, anything, this should actually look like this. Anything that looks like this is okay, everything else will just, throw it away. So we kind of tend to use those pattern matching with lambdas, with higher order functions pretty often. Okay, and now the last thing is, so a few concepts. Like, you will hear some at this conference about algebraic data types, and it seems also like a very the thing about functional programming is not really that hard. The names are confusing, especially if you never heard them before in your life. It's like algebraic data type. That has to be pretty weird, right? Whatever that is. But apparently, if you read about a little bit about category theory, you tend to see, let's say you have a type system that only have 3 types: string, integer, and double. Right? That's all you have. Can you construct any more types out of it? If I only have 3 types, well, you could, for example, create a tuple, right? If I have type string and I have type integer, I can have a new type which would be like a tuple of string and an integer, right? So this is something they call a product. I could also have a type like either type. I could have a new type. I would call it or, and or would be either string or integer, one of those 2 things. And this is something they call coproduct. So you have product, which is, think of a product like an AND. This and this, string and integer. Coproduct is a sum. So it's either string or integer. And this is the only way how you could expand your types within your type system. And algebraic data types are nothing else as this ability to reason about your structures in ANDs and ORs. So I'm saying here, for example, a figure is either rectangle or circle, right? I'm using this or. It's either a rectangle or a circle. But the rectangle type is with integer and integer, right? So I'm constructing. So this is just ability to construct new types that you can reason about within your program with ANDs and ORs. And this is how we basically do it in Scala. So here there you have another one, which is more in a recursive structure. So I have an expression, and an expression can be sum, multiply, or int value, where sum, for example, is expression and expression. Does it make sense? Or are you lost at this point? You were more excited 35 minutes ago.
What exactly about that makes it an algebraic data type?
Algebraic data type is basically nothing really. It's just a name. It's just the fact that you can create your types out of ANDs and ORs. I have existing type ints here, and that's it, right? I have in this example, I have just type int, and I just created a type figure, which I'm using or, because figure is it's either a rectangle or circle, and rectangle, let's say, is integer and integer.
So is the abstract the algebraic data type, or are the derivatives the algebraic data type?
The thing is, what is algebra, right? Algebra is like this portion of math where you define some part of symbols, and then you define methods how to reason about those symbols. And it's pretty much the same thing. You define your symbol is going to be in this type of figure, rectangle, and circle. Those are your symbols, and the operations that you can do on that symbols are going to be your functions. That's just a name. If that's confusing you, let's just move on, because the time is flying pretty fast, and those are just basics. All right, then there's an option. Okay, I will slow down. I'll promise you guys I will slow down, but I want to, because those things you can still read on your own. What I want to talk about are stuff which are not well documented, and those are the things I would really like to tell you what those are. But whenever somebody is telling you about algebraic data type, they are talking about some times which are just created with those ands and ors. But this was supposed to be a recap for Scala. So Scala has we will be using option. So hopefully you guys are familiar with options. The option is basically either holds your value or it doesn't, right? So here I'm just saying I can either return none. So I'm just saying, so this function just takes some input and returns an option of integer. So I'm saying for blah, I will not give you a value because there is no value for blah, but for anything else, it's a sum. So there is a value, but it will be closed or within the option type. There's another type, either type, but we will use the either type from Scala Z, which is called disjunction, and it looks like this. And people might think, oh my God, another operator. But if you think about it, it's just whenever you see this, it thinks of, it's either this value or that value, right? And it's something's going to be on the right. Actually, the class that represents the right value is like this one, and the other one is this one. And basically, that's what it's doing. So that's either type, and then you can pattern match against it. You can call map functions on it and all that. The last type that we're going to use is task, and task is specifically from Scala Z. This is our IO stuff. So it will be doing things underneath. So just to give me an example, here I have a function that is called fetch user, and it takes an ID of the user, but it's not giving us a user. Normally in imperative language, you just say, give me a user, right? If you're using Java or Scala the Java way, you would just say, give me a user, and this would be like a function that you would here do all those little craziness like JDBC calls or hibernate or whatever. This would throw your exceptions, all that weirdness. We are doing something else. We'll give you a user, but that user is closed over task. So when I actually call fetch user with 10, it's not really doing anything. It's not calling JDBC calls. It's not doing any magic that will actually trigger the changes in the real world. And that will be calling database or whatever storage system that you have. All it will do for you, it will just return you a task of a user. That's all it's actually doing. It's still just a value that you can reason about. Well, you cannot really reason about a lot about task, and we're going to talk about it at the end of this workshop, because really what you get is a value. Awesome, right? It's telling you at some point I will give you user, but it can do anything in it internally. It can launch nuclear weapons. It can send an email to your mom. But eventually, what it promises is, mine might just launch nuclear attack. But what it promises is, if you at some point will call me, I will give you a user. So if you are familiar with future. In Scala, this is exactly like future, but on steroids. Because the difference is, if that was returning a future, right? It wasn't a task but a future, the calculations will be already running. You would still you might be waiting for the calculations. The nuclear attack might still be going on and all that. But already once you have this internally, there is some thread which is running your calculations. Here, nothing happens. You just get a value. And to trigger the calculations, you will have to call user unsafe perform. And there are many different methods how you can call it, but the one we will be using is a synchronous one. So unsafe perform sync. And it's called unsafe for a reason. It's just telling you, you functional programmer, you calling thing that will actually trigger changes in the world. And normally in functional programming code base, you will call this method only once. If you call it twice, you're doing something wrong. So we will have different functions that we have one function which will give you, for example, a user, a different one which will give you something else, and you can compose them together, and we will see how that happens. And so we can reason about things that will be eventually evaluated. But to get that value, you call it this, and you call it at the end of the world in your main method. Now, obviously, things can happen, right? Within task, there could be a code which would look like this. New, let's say I have a case class, DB exception, right, which extends runtime exception. So I could just throw that a DB exception here, right? Because why not? And now if I call this unsafe perform sync, obviously the whole thing will explode, right? It's just underneath there was an exception thrown. Like we can imagine JDBC calls to your database or whatever will throw an exception. So if you go to Scala's code base and you will find task there, you will find few methods which are pretty useful. And one of that methods is attempt. So what attempt will do, if it's just saying, given that you have a task of A, so you have a task will return your value of A, you kind of feel that there might be some exceptions happening within it. You can call attempt on it, and what it will give you, it will just give you yet another task. So nothing else is happening so far. It just gives you another value, and that value will right now return you an either type. It will either return you an A or a throwable. So in our example, if I called here user attempt, what I will get in return will be a new task, which will be either a throwable or user. Okay, does that make sense? There's also a way to. So for example, what I could do, let's say, what we can do with your user. Let's say you're not really interested in the user, you're more interested in the login of that user. Does our user have login? Yes, it has. So I'm not really interested in the user, I'm interested in the login. So let's say task of string. So because I can still, even though that value is not being calculated yet, I can still reason about the value that it's eventually going to be calculated. So I can call map on it, and map takes a lambda expression that will give you that user, and you can do something with that user. So I can just say, user, and I'm only interested in user login, something like that. So even though it's still returning a task, nothing yet happened, right? Nothing, like not logging, but login. Nothing yet happened so far. I can already reason about the value that I will eventually get. Does that make sense at this point? I can reason about, so I can do different things to it. I can do some magic. I can compose with this with other tasks, mangle with those values, even though nothing still is going on. That's why you can actually do stuff in functional programming, even though you will eventually call unsafe perform sync only once, because you still have ability to fetch that value and do some reasoning with it using lambda's expressions. So now there's another way to actually, but you know what? Because it's already 11. Hey, I will skip, or maybe I'll just show you guys. There's one more method that you could actually use on task, which is called handle with. So it's another. So it's saying like it takes a partial function. So think of it as a function that doesn't deal with all the arguments that it has in the domain. So it's saying like, oh listen, if that task will actually throw this particular exception, whatever that exception is, instead of returning that, throwing that exception, return a value of type B, whatever that B is. Well, not really. That B has to be something that extends A. So just if that looks weird, let me just show you quickly an example. So we have now right now login of task, right? But that fetch user, as we already know, sometimes from time to time might just throw an exception. So and we know it might be a DB exception. So what we could do, we could just say login handle with. And handle with will take as you guys see, a function that goes from throwable to task. And now this is the moment when we can use that pattern matching. So we could say if that is DB exception, right? If that's the case, then let's say the value of that string is going to be, I don't know, not found, right? Because whatever, not found, and that's it. That's all you do. So still, the type of that thing is going to be task of string, because what will happen if the fetch user actually gives you a user, right? If we actually have a user for number 10, then we map over that user and we take login from it. However, if there's an exception, like for example DB exception, we're just saying, well, return not found, and that will be the value of that string. Does that make sense?